and I'm really excited to share my knowledge with you guys about Swift macros. So today's tool is a very interesting tool. Um, the first look at it, you will think that you are learning, a magical tool in Swift, but it's actually an easy one to understand. It's simple as running a simple logic for your code. So let's start by giving a small introduction about Swift macros and what is the meaning of macro basically. So in Swift 5.9, and this was released, I think, on 2023, Apple introduced something called Swift macros. And the idea of Swift macros is basically to be able to generate code at compile time for you. So basically, what that means is that you can generate any repetitive code in your code base at compile time without, having to rewrite it every time. So the advantage of macros is basically remove a lot of boilerplate code from your code base. Okay, and also it makes your code more clean because basically you can if you have like a let's say for example a certain template for you have for all the objects you create. So for example, if any object you create, you always add an init for it, and this init takes an integer, and this integer is used to set a value called counter, for example, and this is like a constant template in any declaration for any object. So basically, you can use a macro to generate this piece of code for you every time when you create a new object. And we will see how we can do that and which type of macro we can use for such an example. Uh, and we have like different types of macros in provided for us by Apple, and they are very, very useful actually. And I'm really excited to see what you will use it for. And I used it a lot in my personal projects, and I also introduced it to my colleagues at work, and they liked it so much because, as I told you in the beginning, it seems like it's the magical tool that, removes a lot of code that you were gonna like write, but it's not magical, it's just a tool that executes logic that you write basically. Okay. So first of all, we have two main types of macros. Okay, so we have the freestanding macro and something called the attached macro. Okay, so let me share my screen to also. I want you to see, you know, the article that I wrote that I'm actually reading from, kind of. Okay. Okay, so yeah, you can probably, yeah, you now can see my screen. I hope so. Okay, so this article actually I wrote about Swift macros, so I will leave a link for it in the chat if you want to read it after the session also. So I'll leave it right here. Okay, for you guys. Okay, good, perfect. Okay, so basically we have two main types of Swift macros, something called freestanding macros and attached macros. So freestanding macros is used, or let's say called on their own. What I mean by that, you don't have to attach them to any declaration. You can just call them in your code base alone, basically using the hashtag symbol. So something like the hashtag error and the hashtag work both of them are macros. So what I mean by freestanding is basically you can write them like that. It's like a hashtag error. But let me, yeah, here. Okay. So hashtag error. Okay, something like that, and you say the error message you want. Okay. So what I mean by freestanding that you can write it alone is basically you can call it without attaching the macro to any declaration. Okay. So you can just like call it the step in your code like that. Okay. And two examples, we already have them in our Swift language, is the hashtag error and the hashtag warning. Both of them are freestanding macros. From their names, hashtag warning is used to produce warnings in your code base. So, for example, if you want to have like some sort of to-do list in your code base, you can use the hashtag warning for such thing. And hashtag error is basically used to produce error in your code base, basically. Okay, so this is the first type, the freestanding. Okay, the second type we have is the attached macro, and the attached macro is basically a type of macro that you need to attach it to a certain declaration to be able to call it, and you call it with the at symbol. And this is basically the attached macro. One example we have for the attached macro in Swift is the at entry macro, this one, and it's new actually. This is an example for the attached macro, and actually you need to attach it to the a variable declaration. So for example, something like that. And, yeah. And to be able to call this macro, you need it must be attached to this to a, like to a new declaration basically. Okay, so this is the meaning of attached macro. Okay, and let me share with you a link about the at entry in Swift. Okay, for you to also explore it because it's very useful macro actually. So let me share it with you guys. Okay, in the chat. Okay. So let's continue. So now we understand the main two types of macros. We understand the freestanding macros and we understand the attached macros. Okay. So if we went deeper a little bit, we will see that the freestanding macros have its own type. Attached macros have its own types. Okay. So let's start by the freestanding macros types. Okay. We have two main types in the freestanding macros, and the difference between them is what they do. They both of them are called in the same way, but the difference is what they do, and you choose which one depending on which one aligns with your goal, basically. So we have the first type is the expression freestanding macro, and the goal of this macro is used to create a piece of code for you that returns a value. Like it's used to create some sort of logic, and based on this logic, you return a certain value. So you use the freestanding macro when you want to return something, basically. So for example, again, the hashtag error, okay? The hashtag error is an example actually of the freestanding expression macro, because basically it returns an error, as you see, but we have like an empty error because I didn't specify any message. So if I just add it, you will see that the error is updated. So the hashtag error is an example for the freestanding suppression macro, because basically it returns value to you. It returns something. Okay. The second thing is the declaration freestanding macro, and from its name, it's basically used to create a new declaration. So, for example, you can create a freestanding declaration macro to declare a new function. Okay, for example, If you have like a constant template for how you create a function, you can create a freestanding macro declaration that takes the name of the function as the parameter, and then it creates and declares the function for you. So basically, this is the use of the second freestanding types. So those are the two main types for the freestanding macro. Okay. Okay. Perfect. No questions. Okay. Thing is the attached macro types. Okay. So the attached macro types have more types than the freestanding, and actually most of the interesting and most of the beauty of the macros are in the attached macro type. Okay. So let's start by the easiest one, which is the attached peer macro. This macro is basically adds a new declaration alongside the declaration it's applied to. And the meaning of that is basically, for example, if you have um, like what's it called? Attached macro. Okay, I forgot the name. Attached macro called async, for example, and you added this macro to function declaration called test. Uh, and then this function actually have takes a closure as a parameter, for example. Okay. And the idea of the attached peer is basically you can use this macro to create for you a new declaration alongside this declaration. So for example, what you can do is you can convert this callback function to a async function basically by creating this function. Okay, let me do it. This. Oh, okay, using this macro. So actually, what will happen if you have had an attached peer macro is that when you add it to this function declaration, you will have a new declaration, a new function declaration alongside this declaration. Okay, so basically, this is the idea of the attached peer, and it can be added to any declaration. It doesn't have to be a function. It can be an object or a variable or enum. Any new declaration you have, you can attach a peer macro to it. Okay. The second type is the accessor macro, and the accessor macro, the idea of it is you can add will set, did set, get, and set closures for any variable. So the basically the idea of the accessor macro is you can easily add a get or a setter for a variable, or you can add a will set or did set for a variable easily. Okay. And actually, an example for the attached macro accessor is the at entry macro. I have just sent it to you, and you can see that it is have the type of attached accessor. And basically what it does when you apply it, for example, like here, is it adds a new getter and a new setter for this variable. Okay. Because as you know, actually, you can't have a variable in a stored variable in an extension. Okay. So basically this is not allowed in Swift. But after adding this macro, this variable is not stored a variable anymore because this macro generates a getter and a setter for this variable. So basically, you will not have any errors at this point. So this is like a real example for the attached accessor macro. You can explore and use it in your code base actually. The third type of the attached macro is the member attribute macro. So the member attribute macro is used to add attributes to the declaration you have. What I mean by that? Okay, so for example, you can create like a macro. Let's say make all entry. Okay, and this macro will be applied for on an extension called my macro, for example. And instead of adding the at entry macro every time for each variable you have in the extension, okay, this macro will automatically add this attribute to this declaration. Okay, so this is basically the idea of the member attribute macro. It's used to add attributes to any declaration we have inside the object we applied the member attribute on. So for example, if you apply the member attribute on an extension, all the declarations that are included in this extension will have this at entry macro. If you applied it on class declaration struct enum, will have the same thing. So maybe you have like a question in your mind right now. So how can I customize it? How can I specify when this attribute is added? It's based on your implementation, which we will go on and tackle in just a sec, and based on some conditions you write in the implementation to actually check the type and the declaration that you have right here. Okay. This is the third type. The fourth type is the attached member. This macro is used to add a new declaration in the type or okay. So the attached member macro is basically used to add a new declaration in the extension or in the type you added it to. So for example, let's say for the same example, make all entry, for example. Okay, so the extension is empty. So what this macro will do is you can, if it's like attached member macro type, what it can do for you is basically it can create a new declaration. It can automatically create uh, this function declaration for you automatically without writing any code, basically. But the logic is basically written in the macro logic in the macros implementation. So in the end, you write the code. Um, so this is basically the idea of the attached member. You use it to add new declaration in the extension or in a class or struct or item that you apply the macro to. The last type, which is the easiest one, is the attached conformance. And this basically what it does, it makes the type or the extension that you apply the macro to conform to a certain protocol. So for example, if we have the same macro, and if it is a type of attached conformance, what it will do for us, it will add protocol conformance for us without, writing it. And if this protocol have specific functions inside of it, you will also it will also be generated for you. Okay, so this is basically the attached conformance macro, and this is the last type of the attached macros. Okay, so and this is basically the whole all types of macros we have, and this was important to know before we go into the implementation and how to create our first macro. So before going to the implementation, does anyone have any questions until now about macros, or all things are good for you until now? Okay, it seems like everyone is good and no one have any questions. Okay. Yep. Okay. So let's go into the implementation and let's start and see how we can create our first macro. So first, let's see the problem we are trying to solve with the macro. Let's understand the problem. to be able to start the implementation. Okay, so first, if when you create a URL in Swift, you basically use the URL struct initializer, and you initialize the URL with a string. Okay, okay, but the problem is that this URL is always optional. It's always optional. And you always have to write this guard statement to be able to warp this URL, okay? Which is redundant. Return, return, okay? Which is redundant because you will always repeat this guard with every URL declaration. And this is the first problem. The second problem we have uh, with this declaration with the URL is that if you actually wrote the URLs like this, it will have a value, even though that the URL you have, the URL string you have entered is not valid, but still this URL will not be nil and will have a value, even though the URL you entered is not valid. So it doesn't automatically checks if the string you have is a valid URL or not. Okay, so what we want to create is basically uh, a safer, okay, so a macro that creates a URL without making it optional. The second thing is we want to check if the string is a valid URL or not. Okay, so this basically our two objectives we will tackle, uh, and this is basically the two objectives of the macro. Okay, so the final outcome will be something like that. We will have a macro called hashtag save URL from, and this basically will produce for us a URL declaration without being an optional, and also will produce an error if we entered an invalid URL like this, or no. Okay, let's say, for example, like this. Yeah, to produce an error because it's invalid. And if you gave it something else like a number, it will also produce an error for you. Okay. So it's basically a safer way to create URL in your code base. Okay. So the first thing is you need to decide before implementing your macro is which type you're gonna to use. Okay, which type you want, attached macros or freestanding. Okay, so for us, we don't want to add the macro to a certain declaration or to a certain type. So at this point, we are not going to use attached macro. So we have the freestanding. So we are going to use the freestanding macro. So we have two choices: either expression freestanding macro or declaration freestanding macro. Okay, so does like what we want is to declare something, like do we want to declare to create a new declaration from this macro? Not actually. Not at all. So we are not going to use this one. We are going to use the expression freestanding macro because we want to return something. We don't want to return a value. Okay. So basically, we want to use the expression freestanding macro. Okay. So how to create the macro? Okay. The first thing is you will go to new and new pro no, not project, sorry, not a project, sorry. new package actually. And then you will have like Swift macro, then you will press next as an example, or yeah, doesn't, yeah. And then you press next, then you will specify, the file and so on. But since I already created that, I will not create it right now. And then you will have like a template with those files in it. Okay, the package name will be the same name you entered, same thing as this file, and this file will be the name you entered plus client, and this file will be the name you entered plus macros. And you will have those three folders, and I will explain each one in just a minute. But by now, you may ask yourself, why did we create a new package to create a macro? So to be able to create macros and to inject them basically in your code base, they must be worked in a Swift package, in an SPM, okay? So if you have an existed SPM, you can already introduce and write a new macro in it. But if you don't have SPM in your project and you need to add a new macro for your project, you need to create an SPM, and this SPM will have that declaration and the implementation of the macro. Then inject this SPM to your project to be able to use the macro, okay? And also, if you saw the dependencies, you will see that the SPM you created, it depends on the Swift syntax package, because actually the implementation of the macro uses the Swift syntax package, and uses the Swift syntax actually to be able to detect the parameters you have passed, for example, in the freestanding, or the declarations you have applied the attached macro to. So for example, in our case, the freestanding macro, we will have parameters, and we will explain that in just a minute. To be able to access the parameter and access its declaration, you will basically do that using the Swift syntax, okay? So this is basically how the SPM is structured. So the first thing is how to declare the macro, okay? So let's comment that and let's write it together step by step, okay? So first thing, we said that we want to create a freestanding expression macro. So let's just write that, okay? So freestanding, and let's specify the type, expression. This is the first thing, okay? The second thing is to declare it. Like when you declare a function, you write func, okay, the name of the function. For a macro, you basically write the macro keyword, and then after that you write the name of the macro, which is for us will be the safe URL form, okay? Then you will give it the parameters, okay? Then you will specify the output. Since we have a freestanding expression macro, so we need an output. The output can be a URL or void if you want anything, okay? So in our case, it will be a URL, okay? Then you write equal. After the equal, you basically specify the place where the declaration of, or let's say not the declaration, the implementation of the macro is, okay? So this is basically what the project, okay, or your code base will consume. It will consume this safe URL, okay? After the equal, you basically tell the compiler where is the implementation of this macro, like where the compiler needs to go to be able to implement this macro, okay? So in our case, we to specify that, you use the hashtag external macro, okay? You specify the model, okay, which is basically which folder you have in the SPM under the sources file. So for us, the implementation will be under the my macros, okay? And so we will write that. Then you basically specify the type, okay? I think there's something missing. Yeah, okay. Okay. So basically, the type is basically the structure that contain the implementation, the struct that contains the implementation, and you will understand that just in a minute. Everything will link together. But for now, it's the name of it will be URL macro. Okay. So basically, this is how you declare a macro. Okay. So the second thing is implementation. So to implement it, you will go to the same module you specified in the macro declaration, which is my macro macros. So we will go there in this folder. Then in this folder, we have a file called my macro macro. Okay. So let's comment all of that and let's do it together. Okay. So basically, as I told you, let me split the screen. Okay. And let's go here. Okay. So, as I told you, we specified something called type and we gave it the URL macro. And I told you that URL macro basically represents the struct that holds the implementation of the macro. And this is basically what we will declare right here. We will declare a public struct, and you must declare the access control as a public to be able to consume it outside the SPM. Basically, we'll have a public struct, and the name of the struct must be the same name you specified here. So in our case, it will be URL macro. Okay, but let me rewrite the macro. Okay. The second thing is we have like certain protocols for each macro. So for example, for the freestanding expression macro, the struct must confirm to the expression macro. Okay. And the expression macro, for example, have one function, which is basically the function that is called when this macro is called, okay, which we will implement just in a second, okay. And if you, for example, have a peer macro, so you will have another protocol, okay, called the peer macro, okay, and will have the same function name, but it's like different parameters, and this function will contains the logic for the peer macro. Okay, so every type of the macros we have right here have its own protocol. So in our case, we are creating a freestanding expression macro. So our struct must be must conform to the expression expression. Ah, let me take it. Okay, expression macro. Okay, so and this let's fix. Okay, and this macro have one function we need to implement, and this is basically the function that will contain all the logic for this macro. So when you call this macro, this function gets called. Okay. So I want to show you that. So let me create something. Let me return an empty and let's print, for example, anything. Hello world. Okay. And let's, for example, I want to see the okay. Let's open the console. Yep. And let's open the test and let's call this macro and let's remove what is expected right here. And let's run. Okay. The test will fail, obviously, but let's, okay. Okay, let's adjust the target. Okay, because it cannot be, must be a Mac. Okay. And let's rerun the test again. The test is running. And obviously the test is failed, but it's not failed. It's Uh, uh, uh. Yeah, I have some problem in my packages. So let me resolve the packages again. Reset packages cache. Okay, will fields. No macro. Yep. Okay. Yeah, basically, let me check. So, okay. Yeah. Okay, there's like okay. That's me. Oh, okay. I missed something. Okay, so we need to add like a parameter for the macro because basically we need to check on the string. So I forgot to add that. So we'll add the parameter like that. So now we should compile. Okay, let me see. No macro name safe URL from. Ah, are you sure? Okay. Let me build again. Okay. Let's adjust the declaration. Save URL from. Oh, public. Yeah. Okay. You need to declare the macro as public because otherwise, outside this module, nobody like outside the my macro module, nobody will be able to see this macro declaration. So you need to adjust the access control for macro, and you need to make it public. Right now, if we build, everything should compile, but it didn't. But expect yeah. The problem is that in the basically the macro declaration, because it expected an expression syntax and we didn't return something, so basically it produces an error because we don't have something we to return yet. So let me just try to return anything just to see the print statement because I want you to see the print statement. So come for arguments. Okay, so let me give it an empty string. Okay. Okay, I'll tell you something. Let's give it a 5, for example. What about that? Okay. Okay. Convert. Yeah. And this is it returned 5 as you see, basically. Because and but it didn't print the print keyword in the console because we didn't like run a test or something like that. So the print statement was ignored. But I wanted to show you that the basically what happens when you call the macro is this function logic is what been called basically. So to be able to see that this is the logic that was called is basically the output 5 is basically the same output we specified right here. Okay. So if we change it, for example, to 10, you will see that the output is basically 10. So let me put, we will have an error. Yep. And you'll see that it's 10. Okay. Okay. So this is basically what is called when you call this macro. So let's start and specify the logic we need for this macro. Okay. So the first thing we need to check is the parameter we have. We need to check that the string or the let's say the parameter that is passed to the macro, we need to check that it is a string. Okay, and like it's not. We need to make sure that it's not an integer, for example, and it's not an empty. Okay, so we need to check that it's have a value, and we need to check that it is a string. Okay. So to do that, we first need to access the arguments or the parameters that have been passed. And to do that, we have something called node, which is a parameter to the function expression that is that is basically called when you call the macro. The node is basically what contains the arguments that are being passed to the macro. Okay, so we basically want to check first that there is an argument have been passed. So let argument list, okay, dot first, we want the first argument, else return. Okay. I will explain in a bit how to specify the error, but for now, just leave it, yeah, like just ignore it for now. And in the end, I will explain to you how to specify the errors to produce, okay? So basically, this guard statement is check if the node have have a property called argument list, and if the argument list have first parameter, like we produce the first parameter, because the first parameter in the array, when you use this computed property, it produces an optional value, so you need to unwarp it. So we use the guard to unwarp it, and if it failed, this means that the argument list was empty, basically. And if it's empty, you produce an error called no argument have been passed. Okay. So for example, what happens if we remove this string and we command build, you will have an error telling you missing argument for parameter in the macro. Okay. 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 So this is the first thing we need to check. Okay. The second thing we need to check is the type of the argument. Okay. We need to make sure that it is a string, that is not a number or something like that. Okay. So to do that, we basically need to guard let, okay, segments. I will tell you what is segments right now. Okay. And then if it fails, return, or not return, throw error, type is not string. Okay. So basically what we do is we have the argument list right now, and we have the first element, or let's say the first parameter in the argument list. Okay. Then we have access to the expression, okay, of this argument. Basically, the expression represent the declaration of this parameter, okay. And basically the dot as checks that if this expression confirms to the string literal expression syntax. The string literal, if we went inside, the string literal expression syntax is basically the struct that represent any string declaration in the Swift syntax. Like this is basically how Swift represent any string. Okay, any string declaration or any declaration basically is represented in a tree. Okay, and every declaration type have its own tree structure. Okay, so function declaration have its own tree structure. Class declaration have its own tree structure, and the same thing for a string. The string have its own tree structure. Okay, the tree structure of the string is represented by the string literal expression syntax right here. Okay, so basically what we made in this guard statement, we checked that this expression confirms to the string literal expression syntax by typecasting it to this type. If the typecasting succeeded, this means that it is a string. If it failed, this means that it's not a string. Okay. Then we accessed a property called segments in the string literal expression syntax. I will explain what is segments just in a minute. And if it failed, we will throw this error. Okay, so for example, if we passed 5, we will have an error. Can convert value of type into expressed argument type string. Okay, so this is the first two checks you need to do. Okay, we need to check that there is arguments passed and that is a string. Okay, after checking that it is a string, you need to access the segments. What is the segments? Okay, so this string, for example, this is not a string, but let's say, for example, if I have something like that, okay, string equal, okay, code on laptop, okay. So, for example, at this point in this string, it contains one, two, three. It contains three segments. Why three segments? So every space is a separation between a segment and another. So code and on is separated by a space. So code at this point is a segment, and on is a segment, and laptop is a segment. So every space is a separation between two segments. Okay. So if we removed all the spaces, this consists of one segment at this point. Okay. So basically, you can look at the segments as a way that basically represents the spacing in your string. Okay. And each space is the separation between two segments. Okay. So basically, you need to access the segments to be able to access the string that is passed to the macro at this point. Okay. Okay. So a small tip, I will not do this guard, but you can do it and enhance this macro implementation. Is since we are building this macro for URLs, uh, any URL doesn't contain any space. Like there's no URL that contains any space. So this means that the string that is passed to you will always have a segment of count one, of a length of one. So if it is if like if you had like or like say if the user or the developer passed a string that contains a space to the macro, at this point you will have right here segments that the length of it will be more than one. And at this point you need to produce an error for him, because at this point you are sure 100% this is not a valid URL, because there is no valid URL that contains spacing. Okay, so this is a small tip on the side. So the third thing after accessing the string and basically accessing the segments and making sure that the argument is a string and the string literal expression, we need to access the string itself. Okay, that was passed. Okay, so to do that, we will basically have another guard statement, and we will guard on the case of the string segment, and we'll do that. Okay, so basically what we wrote here is basically the segments. As I told you, it's like an array of segments. Okay, so at this point we are accessing the first, so we are warping the first segment. Okay, the segments are represented by an enum. So if we went to the type of the segments is represented. I want to go inside, so let's go inside. Okay, so the segments are represented by an enum, a case of a string segment and case of an expression segment. So to be able to access the string itself, the case must be the string segment. Okay, the string segment case. Okay, so basically this is what we are doing right here. We are checking that the case of the first segment is a string segment, and the string itself is in the segment variable. Okay, so at this point we will create the URL string, because at this point we have the segment we need. Okay, the segments have property called content. Then to be able to access the string itself, we access the text. Okay, Now we have the string representation for the URL. Now we can create the URL type and make our checks and see if it's a valid URL or not. So the first thing to do is we will create a URL, okay, and we will unwarp it, okay. Then we will make sure that it is, if it is a file URL, okay, a file URL means like a path to a specific file on the device you are using, or if it is a URL that have a host and the host is not equal nil, and have a schema and the schema is not equal nil. The schema represent basically the HTTPS or the HTTP. The host represent the domain basically. So if the past URL have a domain and have a schema, at this point it's a valid URL. And if the URL is a file URL, it's also a valid URL. If it's none of that, we will produce an error called invalid URL. So if we have a dummy string like that, we will have an error right now. If yep, that says please pass a valid URL string. Okay. So this is the last check we need to do before outputting the value. So the output is something called an expression syntax. And basically an expression syntax represents the Swift syntax basically. So it's basically like a string representation to the Swift language, okay? So basically what we need to return a URL. So we will write the URL as if we are writing it in the Swift language normally. So we normally declare the URL like that from a string, and we will just copy that and we'll put it here as we did, and we will just give it the argument parameter, not the argument, actually parameter, the URL string parameter. Okay, no, not the, one second. So at this point, we need to give it the argument, like the same argument we passed here. If it's like a valid URL, we needed to pass it right here. So basically, this is represented in the argument list. So let's adjust the naming of this since is, and yep, this is right at this point. Let's just, okay. So you may ask what will happen if we pass the URL string itself. It will not work because at this point you are passing the text itself. And what we are returning here is not a string, it's like an expression syntax. So what you need to write here is you need to write a declaration or a valid syntax representation. So to do that, to be able to give it the right value, you basically give it the same parameter that was given to you and that we made the checks on, which is the argument that we unwarped the first in the first guard right here, and you will pass it to the URL. At this point, if we wrote sorry, not here. Okay, sorry. At this point, if you wrote HTTP as www.clever. Clever is the company where I work. So let's say Google, for example. Okay, you will see if we expanded the macro by going to the navigator in the top and choosing editor, then expand macro, we will find that the output is URL string HTTPS www.google.com. Okay, and it's force unwrapped. At this point, we are sure 100% it is a valid URL. Okay, so at this point, we have produced a safe URL that is 100% valid URL with just one line of code without doing anything more than that. This is basically the beauty of macros. Okay. Last thing I want to show to you is basically I want to show to you how we produce the error and how we specify the errors we need to produce. So to do that, you just create an enum and you give it a name and you make it conform to two protocols, the error protocol and custom string convertible protocol. And you just specify the cases and you specify the description variable and you specify the output for each case in a switch statement. Basically, if we commented that, let me write it with you again. So basically, it will be something like that: var description confirms to string, and then you make the switch. Okay, this is basically a property that is in the error protocol. Okay, and this is how you produce a specific error for the developer or that is consuming the macro when a specific condition if failing basically. Last thing, to be able to be able to use this the implementation for the macro, you need to pass it to the provided macros array right here, like that. Okay. So for example, if we remove this one, you will need to specify it URL macro, which is the name of the struct dot self, and that's it. Basically, this array represents all the macro types you have declared. So if you have more than one macro, this will also be passed in this array. So at this point, you have created a macro and you can use it in your code base right now. Okay. Last thing is to test it, to test the macro. So to test the macro, it's simple, very, very simple. You basically you make you will find actually when you create the SPM for the first time, you will find a template for the test, and basically you will just add your a custom assertion based on the macro you have created. In the first expression, we have like the call of the macro, and then this is basically the expected output of this macro. And basically, what it does, it basically runs this expression and it sees if the expected value is equal to the output value. So it's right now it's testing. So we'll see what will happen. So test succeeded because at this point the expected is equal to the source. If we, let's say, removed and we have give it invalid URL, at this point it will fail because at this point it will not it will produce an error and the and the test is failed basically because it didn't produce anything and we expected a value. Okay, so basically this is how you test a macro and it's simple as that. And just one more thing, to be able to test it, you need also to provide a macro struct for the test macros, test macros array, and you give it like the a key. It's like a dictionary. You give it the key, which is basically the name of the macro that you use, and the struct that contains the logic for this macro. Okay. And this is basically everything for macros. And basically to use it in your code base, you will just add this SPM to the project and you will be ready to go to use the macro in your code base. And that's it for Swift macros. So does anyone have any questions?
If you don't have any questions now, but you want